All right, harder problems with acceleration. This sheet, you've done numbers 1 to 4, but we've only gone over number 3. So I'd like to go over 1, 2, and 4. So number 1 first. A train starts from rest, accelerates to a speed of 30 meters per second in only 15 seconds. Continues at this speed until it's gone a distance of 6,000 meters from its start. Slows down at this point at a rate of 2 meters per second squared till it stops. So the first thing is how many sections, and there's 3. There's speeding up, there's constant, and then there's slowing down. Okay, so the most important thing is to go through the question and pick out your givens for each part. So in part 1, it says the train starts from rest. So VI is 0. Accelerates to a speed of 30 meters per second. So VF is 30 meters per second in 15 seconds. Delta T1, 15 seconds. It continues at this speed. Okay, so we're into the constant section. Continues at what speed? So it's going to be a VAV, and the speed it continues at is the VF from the first section. So VAV will be 30 meters per second until it has gone a distance of 6,000 meters from its starting point. So the second part isn't 6,000 meters, it's the whole thing. So delta D2 will have to be equal to 6,000 meters minus delta D1, because it's the first part plus the second part that's 6,000 meters. Then it says it slows down at this point at a rate of 2 meters per second squared. So A is 2 meters per second squared, but it's slowing down, so it's a negative, until it stops. VF is 0. And what's its VI? Well, its VI is what its VAV was, because it starts to slow down at the end of the constant section. So its VI is 30 meters per second. Okay? So then the question says, how long is it moving? How far did it go? So really what we're trying to find are the delta T's and the delta D's of each section. Okay, so delta T3, delta D3, and then once we find those, we can add them together to solve for A and B. So if we look at the first section, the first thing we can solve for is acceleration. So A equals VF minus VI over delta T. The VI is 0, so A is equal to 30 meters per second over 15 seconds. So A is equal to 2 meters per second squared. So now with this, we can find our delta D, because we know delta D is equal to VI delta T 1/2 A delta T squared. You could use VF squared equals VI squared plus 2A delta D. I'm using this one just because I don't have to rearrange. The VI goes to 0, so it'll just be delta D1 is equal to 1/2 2 meters per second squared. It's about 1 times 15 seconds squared. So delta D1 is equal to 225 meters. Okay, so now we go to 2. So we can find our delta D2 now, because we know delta D2 is equal to 6,000 meters minus delta D1, right? Because the two of them have to add together to be 6,000. So 6,000 meters minus 225. So delta D2 then is equal to 5,775 meters. And now I can find my time, because I know VAV is equal to delta D over delta T. So delta T is equal to delta D over VAV. So delta T2 is equal to 5,775 meters divided by 30 meters per second. So T2 is equal to 192.5 seconds. Okay, so we already have T1 up here. We now have T2, D1, D2, so now we move to slowing down. So I have a VF, a VI, and an A, so I could find my T, because A is equal to VF minus VI over delta T. So delta T is equal to VF minus VI over A. So delta T3, VIF goes to 0, so negative 30 meters per second over negative 2 meters per second squared, so T3 is equal to 15 seconds. Now that I have T3, I can get T3. Delta D3 is equal to VI delta T, 1/2 A delta T squared. Delta D3 is equal to 30 meters per second times 15 seconds plus 1/2 negative 2 meters per second squared, 15 seconds squared. So the first term is 450 meters, and the second term is minus 225 meters. So delta D3 is equal to 225 meters. All right, now that we have that, we can actually answer the question. So part A says how long? So it wants delta T total, which is really just going to be 15 seconds plus 192.5 seconds plus 15 seconds. So delta T total is going to equal 2.5 seconds, part A. Part B wants to know how far did it go? So delta D total. So we have D1 and we have D2 and we have D3. So 225 meters plus 5775 meters plus 225 meters. So delta D total is equal to 6225 meters. It's done. Number 3, how far did it go while traveling at constant speed? We found that already. It's 5775 meters. And how fast is it going 12 seconds after it started? So 12 seconds after it started, it's here in the speeding up part. So it wouldn't be at 15 meters per second yet. Sorry, so this is C. But we can find how far it went. So this is D after 15 seconds, because delta D is equal to VI delta T 1/2 A delta T squared. No, I didn't ask how far. It asked how fast. So we're looking for VF. So we could use A is equal to VF minus VI over delta T. So bring the VI goes to 0. Bring the delta T up, so A delta T. So VF is equal to 2 meters per second squared times, and it was 12 seconds. So VF equals 24 meters per second. Number 1 is done. Okay? So hopefully all that makes sense. So let's go to number 2. Number 2 is Betty and Bob, and I know I'm not going to have enough room on that bottom, so let me flip over here. So a girl and a boy decide to ride their bikes over a 400-meter track. Bob can accelerate 1 meter per second squared. Okay, so, and I mentioned this on Friday on class. So you're going to have Bob, and you're going to have Betty, and you're going to make 2 sections. This part will be speeding up, and this part will be constant. Okay, it's a race, so obviously they both start from rest. Bob can accelerate at a rate, so A is equal to 1 meter per second squared, delta T, 6 seconds, and then he reaches his top speed, which will be VF. Betty can accelerate at a rate of 0.8, because she's a girl, so meters per second squared, and it takes her 10 seconds to do this. And then she'll be at her top speed. So the two things you want to find about top speed is